Hello all, this is our entry for Red Hat challenge. So first of all, what we are trying to do, we are implementing AI based drug discovery pipeline, that is step by step, using OpenVINO and IPEX, that is Intel optimized Python. So it comprises of these significant steps itself. So it is a multiple stages of drug discovery that we are trying to cover. First of all, we are getting the lipophilicity. Lipophilicity means that how a molecule is affine towards a drug or not. So we'll find that. We've done it using OpenVINO. Then we are finding the binding affinity of the molecules, and after that we are implementing prediction to reaction details that are there, and finally implementing the retrieval augmentation generation with scalable and accessible environment using quadrant. So open Vino ensures efficient model inference, quadrant supports context aware retrievals, and OpenShift provides the infrastructure and scalable deployment. So let us start with the process itself. So we are here with the Red Hat the sandbox that's been given. We created the entire notebook uh, entirely on its own. You see, like the OpenVINO models being created, and I have created a Gradio based application where we can serve these models as one go, because we had a very little space to start with. So let's start with the lipophilicity prediction itself. The application is starting. Just wait for a while. Now if I just pass in a molecule that can be represented in the form of smiles. So smiles are representations of molecules that we have. That's a chemical composition we have. So first of all, we have two methods for inference. One is IPEX, one is OpenVINO. So if I just click on it, it would give the interpretation of the molecule. Just wait for a while. So it says the lipophilicity of the molecule is low, suggesting poor membrane permeability, which could limit its effectiveness as a drug. So you can try out with different kind of combinations of smile strings, and it would work for you. We trained it against a small set of files that we had. Accordingly, the log styles values, you will see it in the GitHub profile itself that it's been given, and you can inference it using IPEX or OpenVINO. So if you just click on OpenVINO itself, you'll see the output. Now let us just go back and see the molecule creations. We'll just wait for a while. So this particular option that you see, it is like generating and scoring new molecule based on initial scaffolding. That is, we are have the binding affinity of the molecule, and we are creating a new molecules out of it. We implemented a generative AI pipeline with the help of autoencoders, where we can generate new molecules using OpenVINO. So we'll just see how it works. So if we give just a molecule name, and if I just change the molecule, you can also change the values of the molecule, and click on submit. You will see different molecule conformers being created. You can infer the model using OpenVINO as well as IPEX. So if I just click on IPEX, you will see results appearing, and the conformers score that are being given. You can also change the conformer values over here. Now this is the second thing. Now we move on to something called reaction prediction and smiles visualization using OpenVINO. Now what we are doing is that we are passing in reactant as well as product smiles, and it would give us the prediction, reaction likelihood, and also the detailed analysis of it. So for this, we are considering first one of the famous reaction, the oxidation reaction. We just take ethanol over here as a reactant of smile. I will just put in the value over here, and I will take another product smile, that is acetaldehyde. If I pass it over here itself, you will see that the prediction likelihood appearing, and also the product molecules. The reactant and the product molecule is there, and you are getting the detailed production prediction analysis of it. Now we have covered the entirety. So the last part that I was trying to go around was with the RAG application itself. So I used a quadrant vector database to pull up all the information that was needed for our molecules to be consumed and converted into a vector DB, and analyzed the similarity of it, and created the RAG pipeline. So if I pass in say benzene over here. You can test it out with butane also. Here I will just pass in the values, and you'll see the details of it. Like here is the product molecules. Now I just click on product reaction likelihood. You'll see true likelihood of 0.71. So it's a complete package that we have tried to implement. It's a complete story of a AI based drug discovery implemented well on Red Hat OpenShift with the help of OpenVINO. As you can see the code itself, like there are a lot of experiments being done, and accordingly we have created. It's there in the GitHub itself. It was a wonderful experience. Thank you.